Welcome to 4.4. We're going to talk a lot about for loops in this one. Let me just make sure I'm not misspeaking here. Yes. For, switch, and do while iterations. Seems like that's the flavor of the day. No, I'm just teasing. No, that's something that we use in almost every language you're ever going to encounter ever. For loops, do whiles, and switches. Switches are not iterations, if I'm not mistaken there. Very well. It's a decision structure nonetheless. So let's jump in. So, a for iteration statement. The for iteration statement handles all of the details of counter-controlled iteration. To illustrate its power, let's rewrite the program in 4.1, and we've already rewritten this, so I'll bring it up just to show you. It's here, actually. And we tested it in the last video. If you missed it, please go back and watch. But in this case, we were able to test. Oh, it doesn't see the array, so let's make that error go away. And there we go. So what we did was we created an array, and then what we did was we made a for loop that we made a for loop that had three separate parameters: an integer, which was initialized as I to the number 0. We then said that while I is less than the size of array has three things in it, so this should be 3. I++, which means increment I by 1 when this iteration ends. And every time it iterated, it was supposed to print the array position value is and the array position. So we can test this really fast just to show you how it works yet again. Let me comment out the rest of this code because I just don't want it to fire while I am testing this. So here we go. Let's test it. And there we go. There we go. Now, you see these other values in there. Size of gives you more than just the array. As a matter of fact, I'm not a fan of that. So let me see if I can change that up just a bit. For loop array C. And let's see if I can actually clean this up a bit. It's a little wonky. Oh, those are the memory representations of the values. Okay, I can understand why that was thrown. Get array size C. No, not C++. I don't want C++. Thank you. And I think it's going to say size of. Yeah, size of. I mean, in this case, I guess size of is the that's just the way to do it, so there's really no way around that, unfortunately. But it ran, and it did exactly what it was supposed to do. So let's not opine about that too much, and let's jump right back into the text. When the for statement begins executing, the control variable counter is initialized to 1. Then the loop continuation, and we spoke about this in the last video, but for the most part, what essentially happens is the for loop runs, and I can actually do a breakpoints and then show you what's actually happening. So right now it started, and right now if I look at right now nothing's initialized, but if I said continue, you can see that I equals 0, as it should. Size of array equals the array, and I++ will increment when the iteration ends. Now the array position value is what the array ID is, so at this point let's go ahead and run this and see what happens. Looks like I got 1000. That is correct because 1000 is in the 0th position. Remember that this I represents the index of the array, or the position that I want the array to pull the value from. So at that moment I was equal to 0. So what was at the 0th position in the array? 1000. So array at the 0th index is 1000, so it prints it there. And if I did it again, it would say 100 because I equals 1, and then it should say 10 because I equals 2. And as you see, the second iteration occurred, and it went right back into the loop because I is equal to what? Right now it should be equal to 2. And 2 is less than the size of the array, whatever that is. Apparently it's not 3 like I thought it would be, but it's like 7. But that's not important. So let's finish that off, and we receive 10. And bada bing, bada boom, there we go. And that's the way it works. And it will iterate as long as the size of the array is greater than, or I is less than, the size of whatever, or whatever's on this side. And remember, I is just a variable, so you can change that to be whatever you want it to be. You can make it your name, you can make it your dog's name, you can, you know, make it mom's name. Hey mom, you're now the index. It doesn't matter. You can name that at whatever you want, but I name it I because that's just the industry standard, and that's what we do. But there are situations where you have nested for loops. Verboten. Try not to do that. But sometimes you have recursive calls that have nested for loops, and so what you'll essentially do is for int, and then you'll have another one in here that says for int j equals 0, and then you just keep going down the alphabet until you reach your nested end goal. But please, for the love of all that is holy, please try not to do nested for loops or nested anything. If you can avoid nests, avoid them at all costs. So let's remove these breakpoints because that would be a pain to deal with when we come back. And back to the text. Oh, you didn't go away. Back to the text. All right. So we spoke about this. Because the control variable is now equal to 2, and we just went over that as well. All right. So let's talk about the header components, something that I just spoke about, but we'll talk about it again in the context of the text. So notice that the for statement does it all. It specifies each of the items needed for counter control iteration and a control variable. Let's look at the for loop. So for int counter equals 1 or I, you can put I there. It doesn't matter. It's just a variable name. It's just a placeholder. While counter is less than or equal to 10, increment counter by 1. That's all that's saying. These three parameters are the same across JavaScript, Java, C#, C, C++, PowerShell. Doesn't matter. This for loop transcends all languages. This is exactly the way that for loop will operate. Python, doesn't matter. Perl, I'm just thinking of all the languages that I've written in and I know of. You know, these three parameters are the same across all languages. All of them. So once you learn one for loop, you've learned them all. As a matter of fact, to be quite honest with you, the if else branch is the same across all languages. Once you've learned one, you've learned them all. The do loops, the while loops are the same across all languages. Once you've learned one, you've learned them all. So if someone says, hey, are you a Java developer? You can literally tell them, yes, I am. Because I understand the way the fundamentals of Java works, and I've worked within the constraints of the language, so therefore I understand Java. Now, they might ask you a more detailed question after that, which is, do you know J2EE, which is a Java framework? And the answer to that is no. Frameworks are completely different from the languages. Just because you understand the language doesn't mean you understand the way the language goes together, or how the frameworks put the language together. It's like building a house. There's many different types of houses. There's townhouses, there's mansions, there's two-story houses, one-story houses, there's split houses. They all pretty much have the same components. And if you understand how to build one house, you pretty much understand how to build them all. But that doesn't mean you understand the blueprints of another one. Think of a framework as blueprints. This is a blueprint to the way it should be built. Now, in most situations, you can read the blueprints and know what to build. But in languages, it's a little different. Understanding the blueprints is almost like knowing how to play a symphony by heart. So, frameworks is what really drives people up a wall, but it makes life a lot easier. Either way, that's my rant for this one. Let's keep on going. For a control variable defined in a for statement's header, attempting to access the control variable after the for statement's closing right brace is a compilation error. Alright. Off by 1 errors. This is what happens when your iterations are off just by a little. So this counter is greater than or equal to, or less than or equal to 10 could be a problem if you initialize counter to the wrong number. If I initialize counter to 0 and I said counter in the loop when counter is less than or equal to 10, what's going to happen? It's going to iterate 11 times. It iterates for the 0 and it iterates for the 10. And then it will stop. If you only have 10 values, you don't want that. So if you incorrectly wrote counter is less than or equal to 10 in this where is it here? So they initialize their integer to 1. I always initialize it to 0. Therefore, this less than or equal to 10 can't happen. It has to be counter is less than 10. So it only iterates 10 times if I have a 0 here, which is what you saw when I developed my for loop. It's 0. If this was 10, this will iterate 10 times. If I made this a 1, it'll iterate 9 times. But if I want 10, I have to make sure that I am counting to 10 like a good third grader. It's all just arithmetic. I'm not trying to insult anyone. I'm just being honest. It's all just arithmetic. Counting. Making sure that the discrete mathematics. So let me rant for a second here. Discrete mathematics is nothing but using the lambda expression to collate like objects. That is it. That's all it is. A lot of individuals get tied up about it because they're like, that's not really math. Well, it is, but it isn't. And I understand why it isn't. I do also understand why it is. Discrete mathematics groups things in a way that allows us to more easily quantify what they actually mean. Now, that's the layman's way of explaining it. It's way more complicated than that, but really all it boils down to are 2 numbers that are important to you in discrete mathematics, computer science, and the use of the lambda expression. 0 and 1. That's it. There's only 2 numbers you really have to care about. 0 and 1. Is it on? Is it off? If it's off, do X. If it's on, do Y. With that being said, if I look here at this right here, if you incorrectly wrote counter, it really just boils down to, did the computer count 10 times or not? And if it didn't, knowing that, and that's the part that's the hardest, knowing that it didn't do that. This is a logic error. And it's not going to throw when this happens. I've done this hundreds of times. That show, Are You Smarter Than a Fifth Grader? Sometimes I feel like I'm not. There are times I feel like I'm not. And I have been doing this for a long time, and I sit there and go, but why isn't it working? And then I take a breath, I take a sip of my coffee, and I go, oh, I did that to myself. Oh, you know what? Maybe I need to go take a break, go for a walk, take a nap, do something else, because I'm making silly errors. And that's what it boils down to. Either way, this is a logic error, and it can be a very aggravating logic error to get indeed. And don't worry, I look for it. So when you send me your code and say, I don't know why it's only doing it 9 times, I'm going to say, oh, it's because you initialized your integer to 1 instead of 0, or you're just not looking at the right things. And that's fine, it happens. You know, those kind of syntax errors, they happen to everyone. As a matter of fact, our logic errors, they happen to, there were developers that I've been working with, they've been in the developing for 40 years. And simple errors. Not because they just didn't know, it's because they were tired, or they just weren't thinking about it, or they thought they did something they didn't do. It just happens all the time. So don't feel bad if this happens. This is called a off by 1 error. It's called a I messed up error, you know? But either way. So, general format of a for statement. The general format is the initialization, the condition, and the increment. We've spoken about this, and we've conversed about this, conversate, however you want to quantify that, many times. And I don't know if this is the 7th time. I hope it's close. But the for loop has an initialization, which is when you initialize your variable and give it a value. You have your condition, which tells the for loop when to stop. And you have your increment, which increments the initialized variable. Comma-separated lists of expressions. These are wonderful. If you ever get a CSV, these are great. Because you can always break the CSV up and at the comma, and it's all relative. It's all the same. So, the commas are as used here, and just for those who don't know what a comma-separated list is, I will open up Notepad and show you. So I have Notepad. And so on and so forth until the end of all time. Basically, what a comma-separated list is, it's a list where the values are separated by commas. As a developer, that's wonderful, because now I only have to worry about whether or not I know which each value is because it's separated by commas. And I can split this string, because it's normally a string, I can split that string at the comma and get a very beautifully large array of information that doesn't take any work. So, the comma operator is often used in the for statement. Its primary use is to enable you to use multiple initialization and or multiple increment expressions. For example, there may be 2 control variables in a single for statement that must be initialized. So, using a comma in your for loop to initialize 2 separate variables, 2 separate increments, or 2 separate conditions is how you get more than one Boolean expression in your for loop. It'll look something. Oh, I didn't show you. Well, I can show you then. It looks something like this. So let's say I wanted I wanted 2 indexes. I think I say int j equals 0. And guess what? It doesn't work. Why? Why do you not work? Expected identifier. Like that? Why don't you like it? Should have worked. Either way, that's the way you do it. I don't know why it's not working, but maybe that's why they didn't write it in the text. Place only expressions involving the control variables in the initialization and increment sections of a for statement. Manipulations of other variables should appear either before the loop or in the loop body if they execute once per iteration, like incrementing or decrementing statements. Give me 1 second. Just want to see something. Okay. The 3 expressions in the for statement are optional. Yes, they are all optional, and you don't have to fill them in. Sometimes they're not necessary. Sometimes you know when it's gonna end. But for the most part, I always fill them in. If the condition expression is omitted, C assumes that the condition is true, thus creating an infinite loop. The condition is the second parameter. The I is less than size of the condition that stops the loop. If you don't fill that in, it'll become an infinite loop. You may omit the initialization expression if the control variable is initialized elsewhere in the program. So if you already have an index, you don't have to tell it to make one. You can just use one you already have. The increment may be omitted if it's calculated by statements in the body of the for statement, or if no increment is needed. So. And increment expressions act like standalone statements. We've seen this many times. As you've seen, counter equals counter plus 1, counter plus equals 1 is a shorthand for counter equals counter plus 1. But if I'm incrementing by 1, I can just say counter plus plus or plus plus counter. What's the difference? The pre-increment counter increments counter before the expression is run. The post-increment counter increments counter after the expression is run. What's the expression? The line that you wrote that on. So if I had counter plus plus written on this same line here, then what will happen is it'll increment after this whole entire line runs, and thus print the number that counter was before it was incremented. If I say plus plus increment here, then what will happen is counter will increment first, and then this expression will run, thus giving you the number of the incremented counter rather than the number of counter before it was incremented. Hopefully that wasn't too confusing, but if it is, just go back a couple of videos. We actually went into great detail about this. Infinite loops are caused when the loop continuation condition in an iteration statement never becomes false. To prevent infinite loops, ensure that you do not place a semicolon immediately after a while statement's header. In a counter-controlled loop, make sure the control variable is incremented or decremented in the loop. In the sentinel-controlled loop, make sure the sentinel value is eventually input. So, notes and observations. The initialization, loop continuation condition, and increment can contain arithmetic expressions. Yes, you can do this. It's cryptic and hard to debug when you get logic errors, so I would suggest you not. But you can, if you would like. The increment may be negative, which is true. You can decrement this, by the way. If the loop continuation condition is initially false, the loop body does not execute. Instead, execution proceeds with the statement following the for statements. So loop continuation is this condition. If it ends up being false, or actually no, that's not true, but either way, if it's false, then the for statement will not loop anymore. So, we actually spoke about a lot of this already. Notice there's no var, or there's no int here. That's because counter was probably initialized before the for loop was written. Notice you're using a pre-dec increment versus a post increment, which means that this will not run 9 times, it will run 10 times. Although the value of the control variable can be changed in the body of a loop, this can lead to subtle errors. It's best not to change it and to put it in the parameters. So, you establish your initial value of control, which is your unsigned int counter equals 1. Is counter less than or equal to 10? Yes. Print the counter. Increment the counter, try again. Is counter, and it'll just go until 10 is the value. The following examples show methods of varying the control variable in a for statement. So, vary the control variable from 1 to 100 increments of 1. Notice there's no int, that's because I was initialized before the for loop was written. So you have the pre-increment I, you have the pre-decrement I. You can do it in steps of 7, so I plus equals 7. You can do it in steps of -2, going in the opposite direction, so I negative equals 2. You can do it in steps of 3, and you can do it in steps of -11, all the way down to 0. Your for loops can go positive or negative depending on how you want to quantify what those are, so it has a lot of power. Limit the size of control statement headers to a single line if possible. So, here's a use of the for statement. You have an unsigned int sum that equals 0. The unsigned int number equals 2. Number is less than or equal to 100. While number is less than or equal to 100, increment the number by 2. So what they should get is the sum plus equals the number, and then printf the sum, which is here. And basically it just adds the sum, the number to itself until it reaches a summation of 100. Until number equals 100, that is. The body of the for statement in figure 4.5 could actually be merged into the rightmost portion of the for header by using the comma operator as follows. And there you go. The initialization sum equals 0 could also be merged into the initialization section in the top here, as you saw I tried to do and failed miserably. So consider the following statement. A person invests $1,000 in a savings account yielding 5% in interest. Assuming that all interest is left on deposit in the account, calculate and print the amount of money in the account at the end of each year for 10 years. So they wanted to see the amortization. Use the following formula for determining, they want to see the value of the amount deposited at nth year. Amortization is the value of a loan as it depreciates as you pay it off. I apologize. So basically we want an if loop here, a for loop here. And here we go. So we have double principal equals 1,000, double rate equals .04. We're going to print, output table column headers, and then we're going to calculate. So unsigned year equals 1, while year is less than or equal to 10, plus year. Calculate. Double amount equals, and this is the function, this is the equation they gave us. Amount equals principal, in parentheses, 1 plus rate to the nth power based on years. And it will run that over and over again and then print that into a table. And there you go. That's the value of every year. The for statement executes the body of the loop 10 times. And I just explained how that goes. So we're going to keep going. The header math.h should be included whenever a math function such as pow, power of, is used. So in this case, to get the power of, they use pow, P-O-W, to do that, which is a math function to be specific. How did they get the year? There it is. So this is a actual function. The power of gives you the what's inside the parentheses, or what the number is that the power of is going to be of the exponent, and then the second parameter is the exponent itself. Okay. And function pow has 2 double arguments. Yes, I just explained that. This information is contained in something called pow's function prototype. The function prototypes of every language have specific functions that are inherent to that language. So pow is a function of the math library, just like your data types are functions of a specific data type library as well. A caution about using type float or double for monetary amounts. Notice that we define the variables amount, principal, and rate to be type of double. We did this for simplicity because we're dealing with fractional parts of dollars. Type double is a floating point type like float, but typically, remember I told you there are 2 different data types? But typically a variable of type double can store a value of much greater magnitude with greater precision than float. So I was right. Double is bigger than float. Variables of type double occupy more memory than those of type float. For all but the most memory-intensive applications, professional programmers generally prefer double to float. Do not use variables of type float or double to perform monetary calculations. The impreciseness of floating point numbers can cause errors. Logic errors, to be exact. So, here's an example, or here's a simple explanation of what can go wrong when using float or double to represent dollar amounts. Two float dollar amounts stored in the machine could be 14.234, which prints 14.23, and 18.673, which prints 18.67. When these amounts are added, they produce the sum 32.907, which with the .2 float prints the 32.91 because it is rounded up. Thus, your printout could appear as this. Clearly, the sum of the individual members as printed should be 32.90. Try not to use float if you can avoid it. Formatting numeric output, and we talked about this, but you can use between the percent and the F, you can use that specific situation or that area to define how you want your output to be. The 21 in the conversion specifier denotes the field width in which the value will be printed. A field width of 21 specifies that the value printed will appear in 21 print positions. I don't know how big that number is, but that number is gigantic. The 2 specifies the precision, or how many decimal points you want to see. By default, how many decimal points will you see if you don't specify that? 6. And if you don't remember when I said that, go back a couple of videos to Unit 1 and you'll find it. If the number of characters displayed is less than the field width, then the value will automatically be right justified in the field. This is particularly useful for aligning floating point values with the same precision. To left justify a value in the field, place a minus sign between the percent and the field width, like this. Okay, so I'm going to stop here, and I'm going to call it there. We'll talk about switch statements in the next video. Otherwise, you guys have a good one. Ciao.